Okay, today we are moving into 943. I hope that your 942 practice worksheet went well. Please make sure you are reaching out if you're still not grasping the concept of how to shade solution regions for inequalities and then look for the overlap to find the solution region for a system of inequalities. All right, we are going to get one more opportunity right now in our warm-up to go over the idea of a system of inequalities. So in 9-101, it says review what you've learned for systems of inequalities. That was what we did in 941, and then you practiced that in the last lesson on 942. And we want to figure out where is the solution region of the points that are going to make these two inequalities true. Okay, now the first inequality we see is y is less than or equal to, what is that symbol? The absolute value of x plus 4. Okay, now I know we are not experts at absolute value graphing, so that is where I want to refresh your knowledge of graphing calculators and Desmos. So those of you that the download didn't work for the graphing calculator, maybe need a little review of Desmos.com. So if you come across a graph that you don't know, okay, I am going to go ahead and type in y equals, and I'm going to look at the absolute value. Now on a graphing calculator, you might type in ABS, but they do have an absolute value symbol on Desmos. And we're looking at the absolute value of x, and then we want to go outside the absolute value and add 4. Okay, so there you can see that it is a V shape. The vertex is at 0, 4, and it goes up 1 over 1 in both directions. So we can go ahead and I will use blue on this first one. So we start at 4. Let me adjust my thickness there. We start at 4 and we're going to go up 1 over 1 in the first quadrant, and we're going to go up 1 back 1 in the second quadrant. And we see that it's less than or equal to, so we definitely want to use a solid line to make our V shape. Whoops, undo that. And then there we go. Okay, so that is the boundary line for inequality number 1. Now from there then we want to figure out where to shade. So we see that it is less than, so we go straight down from the vertex. So that tells us that this entire region holds points that will make the first inequality true. Okay, now moving on to the second inequality, we see that, is it ready for us to graph? No, it's not in graphing y equals form. So we need to do some work here. Negative x plus 4y is greater than or equal to 4, and we need to get y by itself. So this is a good review of just some algebra steps. So we have to add x to the other side, and those are unlike terms. So we have 4y is less than or equal to x plus 4. And then we want to divide everything by 4. So we have, and that's not negative, so we keep the inequality sign as greater than or equal to. And we have 1/4 x, and then 4 divided by 4 is 1. So this is what we are going to want to graph. So we need to start on the y-intercept at 1, and we need to go up 1 over 4. Sometimes it's hard to count with the shading. Okay, and then we see that it's also or equal to, so we are going to use a solid line once again. I'm going to extend it. And there is our second boundary. Okay, now to focus on the shading. Whoops, what's going on here? Okay, we see greater than, so I put my pen on the boundary line and I shade straight up, and you'll notice that on my answer key to the worksheet, I kind of figured out what region I was going to shade in, and then most of the time for my second function, I shaded horizontally, so you can kind of really see that overlap. So how many regions are created in this inequality? Well, I see region 1, I see region 2, and I see region 3. Okay, so when we look at the region that makes both inequalities true, we see that the overlap is occurring at region 2. And let's look at a test point really quick. You had to do that on your worksheet. Maybe we use 0, 2. So then let's go ahead and test how about the first function is 2 less than or equal to the absolute value of 0 plus 4. Well, the absolute value of 0 is 0, so is 2 less than or equal to 4? Yes, it is. And then let's go ahead and check that second inequality, and let's ask, okay, let's use the original in case we made a mistake on our algebra along the way. So is negative 0 plus 4 times y is 2, is that greater than or equal to 4? Well, negative 0 is 0, so we have is 8 greater than or equal to 4? The answer is yes. So we have our double yes, so we know region 2. We can be confident with that. All right, so now today what we're going to do is a little bit of an application lesson on how we can use a system of 3 inequalities to solve a story problem. Okay, so normally you guys would do this in your teams, but today I'm your teammate and we're going to work alongside each other to solve the search and rescue problem. Okay, so please follow along. It says, I'm completely lost. Water everywhere I can see. Both burners have failed. Wait. I see land. I'm going to try to land. I think it's... Those were the final words heard from Harold in his hot air balloon. The last time the balloon showed up on the radar, it was near the Solomon Islands in the Pacific Ocean. Our task, we must determine where to send the search and rescue team. Okay, so that's kind of like the big idea. Use the following reports on the next page of the note sheet and look carefully for information that can help us draw constraints. Okay, constraints, whenever you see that word, that's a synonym for inequalities. So we are thinking about 2 things. We're thinking about boundary lines. Whoops. Okay, boundary lines are curves, and we're thinking about shading regions. So that's what we think of when we think of constraints. Okay, that we are going to then try to narrow down and tell the search and rescue team where exactly they should search for this hot air balloon based on the overlap of our inequalities. So let's go ahead and go to the next page. And what we're going to do is we're going to go story by story. We're going to focus on graphing and writing the inequality so that we can see the system take shape. So let's look at the basic facts in the case. The balloon departed from the airport at the very northern tip of the Philippines. The flight was supposed to follow a straight, that must mean linear, path to the airport in French Polynesia. The balloon's last known location was at negative 1,000, 1,000 near the Solomon Islands. Okay, so let's go ahead and take a look at the graph and let's think about, well, I think it's telling us that the departure was here at the Philippines and it was going on a straight path to the airport in French Polynesia. So if we know that right away, can we go ahead and draw in the flight path? I think that's what we're supposed to do. Okay, so we are going to go ahead and connect our points here. And I'm going to extend the line through the entire map, even though we know where the start and stop point was. And then we have to use, you can't ignore any information, okay? We have to use the fact that the balloon was last seen at negative 1,000 kilometers, 1,000 kilometers. If you notice, we have our scale down in the bottom right corner. So if we go on our graph at negative 1,000, 1,000, okay, that puts, obviously, the balloon at the Solomon Islands. So it got off of its path. All right. So where was it off of the path? It was off by going below the boundary line. Okay, so that to me seems like we have now narrowed our search into the bottom half of the graph. So let's think about the equation that we could write, or the inequality that we could write for this scenario. Well, it's linear, y equals mx plus b, and we see that the y-intercept is at 2,000, and it seems that the slope is going down 1,000 over 2,000 to get to our next lattice point. So let's try to put together our first inequality. What do we have? We have y. I'm going to leave a space, and I'm going to think about negative 1,000 over 2,000 is going to reduce to negative 1/2 x. And what was our y-intercept? It was 2,000. Okay, now we shaded below, so we have to use a less than symbol, and we're also going to continue to search on the path of the flight, so I think we can use the or equal to sign. So this is our first of 3 inequalities. Let's go ahead and read the second. Pilots report from a nearby airplane. For this one, let's use blue. Okay, we were on our way from Australia when we saw a hot air balloon sinking rapidly. I am certain that it crashed south of our flight path. When we left Australia, we traveled 2,000 kilometers north and for every 3,000 kilometers east. Okay, and east is this way. So let's go ahead and look at trying to graph this on the map. Whoops. Okay, so it says that they started in Australia. They have to go from the airport. This is an airplane. And that airplane, it said, was traveling 2,000 kilometers north. So we have to go 2 boxes up and 3,000 kilometers east. So 3 boxes over. Yes, that lands us on the y-axis. And we can go another up 2, over 3 if we would like. So that right there gives us our nice boundary line because they're traveling in a straight path by giving us the slope. So we are going to go ahead and make our next line. And it said that they had seen the hot air balloon sinking south of the flight path. Okay, so south is going to go below. That's a kind of a synonym, I guess, in a contextual way. That would mean shade below. So we see that below the line is where I just started marking, but I'm going to go ahead and use horizontal so that we can see some overlap taking place with our red. But I'm really just focusing on the blue right now. And we can now see that our search is narrowing down. What is our search narrowing down to right now? This region right here. Okay, but we're not done yet. So let's go ahead and try to make an equation for this. So our y-intercept is below the x-axis. It's negative 2 boxes, which means negative 2,000 kilometers. And they gave us the slope of saying up 2,000 over 3,000, which is going to reduce to 2 over 3. Cancel those zeros out. So our next inequality, okay, is y, leave a space for a second, and we said positive 2/3 x, and then minus 2,000, and we shaded below the line, so that's less than, but we're still going to consider that flight path, so less than or equal to. So there is our second of 3 inequalities. Okay, and on the third piece of information, it says, I was a passenger on a flight that flew directly from French Polynesia to Indonesia. I was looking out my window when I saw the balloon going down to the north, okay, so north is up, of where we were flying. So let's go ahead and graph this. So French Polynesia and Indonesia is what we need to find. So French Polynesia is right here, and Indonesia is right here. So let's first go ahead and make our flight path, our boundary line. Okay, and I'm going to go ahead and extend my line as best I can. And we can see that it goes through the origin, so that's very nice. And do we see another lattice point? I think I see a lattice point right here, so we can probably use that to count our slope here in a second. But they said they saw to the north the hot air balloon. So if we go ahead and shade to the north, that's going to be above the line. Okay, so maybe I'll do a diagonal shade because this is our third inequality. Okay, so we can see systems of more than just two. Okay, so let's go ahead and make an equation for that one. We know it goes through the origin, so our y-intercept is 0, and we need to count our slope. I'm getting ahead of myself. So if I go from the lattice point here, we have let's see, let's start from 0, 0. So we're going down 1,000 over 1, 2, 3, 4, 5,000. Okay, so 1,000 over 5,000 is going to reduce to 1/5 in the negative direction. So we have y, leave a space, 1/5 x, and if you'd like to put plus 0, you can, you don't have to. And we shade it above, so that's going to be greater than or equal to. Okay, so now the big question of this story problem is, where should we look for the missing hot air balloon? So we need to look where the red, the blue, and the green intersect. Okay, now we shaded below the red line, below the blue line, and above the green line. So sometimes when you get these intricate problems, you have to think back to the direction that you shaded. If you look at where we went below the red line, below the blue line, and above the green line, it is this region right here. So where is the probable place where the hot air balloon crashed? We would tell the search and rescue team to look at the Samoa Islands, or at and around. Okay, so that is the solution to the 3-part inequality system. Okay, so even though we just did a story problem, what I just showed you in black is the solution to the system, which is where the search and rescue team would most likely find the hot air balloon. Okay, so inequalities can be used. They can be useful for narrowing down places on land or in water that you should look for things based on accounts. Obviously, this situation was simplified for us, but it is a good kind of look at a story problem where you're going to use shading in terms of inequalities rather than just equations. Okay, so that's all we have for today. Kind of a nice, refreshing short lesson. Make sure that you do your homework, and we have kind of one more day in Chapter 9 to go, and then we're going to really review for that Chapter 9 assessment next week. Great job.